Isotopes are the same element with different atomic masses. They have to have the same atomic number because if that changes, then the element also changes. Different isotopes have different numbers of neutrons but the same number of protons. This is because the number of protons determines the atomic number, and the sum of the number of protons and neutrons determines the atomic mass. The number of electrons does not change as long as the atom is neutral because the negative charge of the electrons cancels out the positive charge of the protons. Different isotopes of the same element often have similar chemical behavior because electrons, not neutrons, affect how elements behave with other elements.
Chlorine is the 17th element of the periodic table. It is a gas in its neutral state at room temperature. It is used as a disinfectant in PVC pipes and as a chemical weapon. It has two stable isotopes, chlorine-35 and chlorine-37. Chlorine is never found by itself in nature. Chlorine-35 has a neutral abundance of 76%, while chlorine-37 has a neutral abundance of 24%.
Chlorine-35 is pictured here. There are 17 protons in the nucleus and 18 neutrons in the nucleus. There are 17 electrons in the orbitals, represented by the red pieces of clay on the circles around the nucleus. There are 17 protons because the atomic number is 17. There are 18 neutrons because the atomic mass is 35, and 17 plus 18 is 35. The number of electrons is 17 because it is a neutral atom, and there need to be 17 electrons to cancel the 17 protons.
Pictured here is a model of chlorine's other stable isotope, chlorine-37. In this isotope, there are still 17 protons, because the number of protons remains constant. The number of electrons also stays the same at 17. To cancel out the 17 protons, the number of neutrons, however, changes. Chlorine-37 has 20 neutrons because 20 plus 17 equals 37, which is the atomic mass.